Just want to start off with a large statement really, which is the natural water cycle is broken. So obviously, as we all know, the natural water cycle calls for the rain to fall on undisturbed land, where the majority infiltrates through the soil and into the water table, maintaining a balanced moisture content in the soil and therefore a balanced system. However, through construction of buildings, roads and other hard standings, we're breaking the water cycle. The water then either runs off site or is diverted into an already overloaded sewer system, which obviously impacts the environment, causing this increased flooding, which we're all experiencing at the moment, pollution and a negative impact on wildlife. Next slide, please, Iona. So, what are sustainable drainage systems, or SUDs, and how are they sustainable? So SUDs are drainage systems that are environmentally beneficial, aiming to align the modern drainage system with natural water processes. SUDs, or green infrastructure, can increase infiltration and or slow down surface runoff, reducing the negative impact caused by non-sustainable stormwater management systems. The benefits of SUDs are creating by mimicking the natural flow of water, so preventing water pollution, slowing down surface water runoff into natural water courses, reducing the risk of flooding, and reducing the risk of stormwater overburdening the foul sewers during heavy rain. And of course, most importantly, recharging the groundwater to help prevent drought and maintaining a balanced system. So, Hydrorock Natural Aquifer Blocks, what are they and where do they come from? Well, they were developed in the Netherlands, renowned for their global expertise in water management, and this follows 10 years research and development by Rockwool. It's a highly absorbent aquifer, so 94% water storage, and it's 100% natural material made from basalt rock. Hydrorock blocks, the idea is that they replicate the natural aquifers by capturing, holding, and releasing water. Hydrorock has been installed in the Netherlands, China, Singapore, Middle East, and various European countries, and now introduced into the UK through Hydrorock Solutions. Next, yeah. The natural Hydrorock blocks, what we do is we offer the full holistic solution for surface water management. So we're making space for water, allowing you to create a natural aquifer where the water cycle is broken. The Hydrorock systems are, well, first of all, they're simpler, they're de-skilled. You literally just push these blocks together. They're easier, no assembly required like crates. They're faster to install, quick to install because they're also pre-wrapped, cheaper. The systems with Hydrorock, they're more efficient and therefore you generally get a smaller solution, less to excavate and spoil away. Certainly safer because you have less vehicle movements and reduced time for traffic management, and of course greener because they're made from basalt rock, which is a natural product in plentiful supply. And also end of life, Rockwool will also recycle free of charge at the manufacturing sites, which they generally just melt it down and reuse it then in their thermal insulation. There are here's just a glance really at some of the benefits of Hydrorock. So Hydrorock, as I said before, offers a truly green and proper SUDS, not just sump and pump with a lot of the current systems which do not fix the broken water cycle. The Hydrorock's natural aquifer makes space for water where it's required, and the installation costs can be 20% cheaper, and this is an absolute minimum. It can be significantly more. We're sort of talking, 40% plus in many cases. Basically, the earlier Hydrorock can engage and influence the design, the greater the savings. So Hydrorock provides a full holistic solution that can retain water on site and or control the rate of water entering local water courses, which I'll talk about later. And finally, I just highlight the filter runoffs where Hydrorock captures particulates, PAHs, metal from exhaust, tyres and brakes. This is where particles bind to the rockwool and are removed from the water. As you can see, Hydrorock can be used across a complete and diverse set of locations, presenting better solutions than those currently available. It's easy for retrofit, where you can easily install these lightweight blocks from small to large-scale projects. With Hydrorock, they remove the need to connect rainwater to the already overloaded sewers on new builds. In fact, you can actually disconnect existing rainwater pipes from the sewer and put the water via Hydrorock back into the ground where it belongs. Because the Hydrorock blocks are so versatile, you don't have to have a central system. You can actually spread the blocks around the site, which in many cases create extra footprint to build upon. I'd also draw your attention to irrigation, as Hydrorock allows the water to go where it is most needed. Hydrorock have actually developed some exciting irrigation systems that are currently being used in the Middle East. So how is Hydrorock different to other suds? Well, this is a quote that you can see on the screen now, which was from one of our customers. They reflected back to us saying, well, Hydrorock has the flexibility of gravel with a void ratio of crates. So just to unpack that, like crates, Hydrorock has a void ratio of 94% compared to stone that has 30%. So a Hydrorock solution is a third of the size of stone. Hydrorock is produced from a natural sustainable material, unlike crates, which are made from plastic. We fill our oceans with plastic. We don't want to start filling our land with plastic as well. Hydrorock has the flexibility to be adapted around obstacles. It's just so easy. And when I show you this in one of the case studies later on, you literally just cut the blocks as required, and just the progress continues. I'd also point out that because of Hydrorock's controllable rate of release, water only moves into the soil when the water pressure in the soil is less than the water pressure in the block, maintaining a balanced water content in the soil. And finally, Hydrorock also has a high rate of permeability of 200 meters per 24 hours, making it a very fast and efficient material to transfer water. So on this slide, you can see how Hydrorock on the right compares with crates on the left-hand side. So just looking at the top image, this is showing that there is no infiltration from the crates on the left-hand side. They have to be full before the hydrostatic pressure will start to force the water out. With the Hydrorock on the right-hand side, the infiltration starts immediately as it is working on capillary action and allows the water to move from the block to the soil. In the middle image, again, looking at the crates on the left-hand side, water is only infiltrating from the sides, as the base of a crate clogs up fairly quickly, creating an impermeable base. With the Hydrorock blocks on the right-hand side, water is infiltrating through the sides and the base, which significantly increases the working surface area, which, as you can see in the bottom images, allow the water to infiltrate out of the Hydrorock blocks significantly quicker than the crates ready for the next rain event. I'll also point out that the crates never truly empties because the hydrostatic pressure drops at the water levels from the crates, so that the base gets clogged up, creating an impermeable layer, and therefore has to be oversized to allow for this reduced capacity. Amongst its many other characteristics, Hydrorock is also load-bearing. I've just added some extracts from a table on the right-hand side. I can send you more detailed information if you require, but basically Hydrorock has its own inherent strength, which can be seen in the first table. So Hydrorock is produced in various densities, and the higher the density, the higher the load-bearing capacity. So for example, on the low density blocks, that can withstand 2 tons per square meter, increasing to over 7 tons per square meter for the higher density blocks, and increasing on the higher density blocks, etc., etc. The load-bearing capacity is further enhanced, obviously, by the depth of the overburden that spreads the point load. Gravel plates also have a similar effect. In fact, Hydrorock can be designed to withstand full HGV loadings and be installed under highways. So Hydrorock blocks basically work in 3 ways. You've got attenuation, so slowing down the rate of flow. infiltration, allowing the water to return to the earth, and irrigation, where the Hydrorock block releases water to the trees and plants at a rate the ground requires, or a combination of the above. As you can see from these photographs, Hydrorock has the flexibility to be used for all situations, and Hydrorock systems are readily scalable from small modules serving individual housing units to large multiple modules serving big sites. I'm just going to draw your attention to the photo in the top left-hand corner, which is a domestic soakaway, where it looks like the surgeon has excavated this one. It's so neat. But what it does, it shows you that you only have to excavate the minimum volume. There is no need for an extra 1 metre width around the perimeter to provide access to wrap the product as it is already wrapped. With the increase of impermeable surfaces, Hydrorock also have a solution with grills and channels, which are ideal for retrofit with minimum disruption. They are ideal to manage localized surface flooding. There is no need to connect to the drainage system, just allow the water to infiltrate back into the ground where it belongs. They are a simple solution that's quick and easy to install. We find customers talk to us more and more about how they are having problems with permeable paving, and this provides the ideal solution. As you can see from the photos on the retrofit, you just lift up the blocks and open the ground before installing the Hydrorock blocks, and then fitting the channels and grid on top at finished surface level. Depending on the volume of surface water and the infiltration rates, the size and number of blocks can be designed to accommodate. If I go quiet, I'm sipping some water. And we're back. So, how does it work? Well, this is the basic system of Hydrorock, and basically there are sort of two ways to get water in and two ways to get water out. So, we'll look at getting water in first. We'll look at the picture shown at the top. Water accesses via the filter gully on the left-hand side. The water is circulated via the plastic pipe into the outer blocks and enters the blocks at a rate of 864 litres per hour. So if you have two blocks, which you can see in our top picture here, that will enter in at 1,728 litres per hour. And obviously, if you've got 10 blocks, 8,640 litres per hour, etc., etc. So that's how the water gets in through the outer blocks. Then the middle block is the air vent, allowing the air that's currently in the blocks to be pushed out as the water cascades in. The modules are 3 blocks wide and can be up to 15 blocks long per gully, and each block is 1.2 metres long. The second way for water to enter is using the no plastic solution. We literally just have solid blocks where there are no gullies, no plastic pipes. The water simply accesses the block via the top and cascades in. So as long as the blocks are touching, the blocks will act as a single aquifer, allowing water to move along the blocks at 200 metres for 24 hours. As I said, there's two ways to get water out. The first, you literally take one of those hollow blocks and you invert it, and this allows water to flow out at 216 litres per hour per block. And these inverted blocks remove the need for a hydrostatic break. You invert 2 blocks, the water comes out at 432 litres per hour, 10 blocks, 2,160 litres per hour. The second way for water to be released is by infiltration through the sides and the base due to the capillary action. But unlike crates, as we have already said, which can't infiltrate through the base, Hydrorock is therefore a more efficient and often smaller solution. Or you can have a combination of the two. So if you have an open system, i.e. it's not wrapped in the imperial membrane, this provides static capacity and a dynamic capacity that starts immediately when water enters the system. Again, Hydrorock systems can also be spread around a site rather than a single central position, generally allowing more room for increased building space. Next slide, please. I was about to apologise for these being the wrong way around, but it looks like marketing have outperformed as usual. So what this shows you here is the arrays I showed you in the previous slide, so you've got two arrays here going end to ends. So you've now got 30 blocks long, but still 3 blocks wide. And this gives you a storage capacity of 40 cubic meters. Now again, the water enters via the outer blocks, and again, the air breathes to the middle blocks. But what you have here is for each 3 times 15 blocks, you have 1 gully each end. The alternative way to assemble this with 2 arrays is to have them side by side. So again, for the top 15 blocks, you've got 1 gully. To the bottom 15 blocks, you have another gully. And we end up here with a system that's now 15 blocks long by 6 blocks wide. And again, storage capacity of 40 cubic meters. So hopefully with the magic of marketing, we will now show you a video that just shows you how Hydrorock works. I can't hear any sound of that, Iona.
Holding 400 of water can easily be lifted.
Could you restart that, please, Iona? I can hear it now. Sorry to be a pain. Thank you.
In this short video, we will demonstrate to you the 5 most important features of Hydrorock. Hydrorock is very lightweight, meaning even the largest Hydrorock block, capable of holding 440 litres of water, can easily be lifted and installed by one man. Hydrorock is immensely absorbent, capable of very rapidly absorbing 94% water of its cubic volume, which makes this 8 cubic litre block capable of holding over 7.5 litres of water. But now carefully watch the red line as I push the block into the water. The block's cubic volume is almost the same as the water inside this glass box. Hydrorock uniquely suspends the water within the block, holding it within the capillaries between the block's fibers, helping support the weight of the water. Hydrorock readily releases water, according to the needs of the surrounding soil. As the soil dries and its water pressure drops below that inside the block, water is gently released from the block through capillary action, ensuring optimal soil-water balance is maintained. As you can see, the water is flowing from the block into the dry sand. Similarly, a saturated block placed on top of a dry one will very quickly infiltrate into the bottom block. This makes Hydrorock the perfect rainwater and storm runoff management solution for attenuation, infiltration, and irrigation. The secret to all these amazing capabilities lies hidden inside the block. Let's have a look. Hydrorock blocks have a solid core of very special type of mineral wool, a 100% natural material made from highly permeable basalt rock. The recyclable geotextile membrane covering the block prevents any sand, silt, or other materials entering the block. Hydrorock is incredibly strong, with high-density Hydrorock capable of directly supporting 4 tons per square meter. Load-bearing capacity grows rapidly with installation depth, making Hydrorock under parking lots and roads capable of supporting the heaviest road vehicles.
Thank you very much. Right, so you can see there just how easy it is to cut Hydrorock. It looked like they were just using a bread knife on that, I'm not too sure. You can see that Hydrorock has many unique characters, but just to highlight a few. So for the environment, it keeps surface water on site where it belongs. You can even disconnect rainwater from sewers to reduce loadings to already compromised systems. It's produced from basalt rock, which is a natural material, and we have plenty in supply. We also have no plastic solutions, as discussed earlier. And there's a new phrase that is being used, is nutrient neutrality. And this is all about getting the water into the ground so the soil can manage the phosphates and nitrogen. Again, this can be done through the infiltration process of Hydrorock. It's good for reducing project risk. Hydrorock can unlock some of the most challenging of sites where other systems are not able to perform within the required parameters. It enables quick solutions around in-ground obstacles. Just cut the block around the obstacle, and as long as the blocks are touching, the water will move around the system. And this in turn helps projects stay on time. There is no stop-start or any need to redesign the system when you find an unexpected obstacle in the ground. Obviously, there's significant improvement in cost performance. As I said before, due to the high porosity of 94%, permeability of 200 meters in 24 hours, and infiltration through the base, Hydrorock is extremely efficient, which enables reduced sizing of systems, which in turn reduces the size of excavation, and therefore reduces spoil away and all the associated costs. The speed and ease of installation also prevents high cost of road traffic management and the threat of overrun penalties. And finally, last but by no means least, safety performance. Fewer vehicle movements, traffic management reduced and simplified. You can backfill as you install. You don't have to complete the whole installation first. And it removes the needs for installation workers in the trench. This was a contractor who advised us about this. They were saying no need to have people in the ground to install the blocks. They can just be lowered by HIAB or similar, and therefore no need for shoring to the sides either. So I'm just going to have a quick look at two case studies. The first is at Lizard Lane at South Tyneside, and the second one will be at Tilford Street in Surrey, which is our no plastics solution. So South Tyneside Council, their brief that they had a narrow verge to manage the surface water and wanted to combine the solution with a new traffic calming scheme. So the water was running off from surrounding fields and the golf course and sitting on the carriageway for days. With Hydrorock storage capacity of 94% compared with stone of 30%, the stone solution would need to be 3 times larger than Hydrorock, so there was insufficient room for stone in the verge. There were similar issues with crates. By the time you increase the size of the excavation by additional metre either side to provide access to wrap the crates, you were outside of the verge. And because crates don't infiltrate through the base, unlike Hydrorock, crates couldn't achieve the infiltration rate within the narrow footprint and therefore couldn't empty quick enough before the next rain event. The site also provided challenges with immovable obstacles in the ground that were easy to overcome by cutting and modifying the Hydrorock blocks during installation. So by working closely with South Tyneside Council, their consultants, Linus engineers and contractors, BCE Northern, we were able to design and build the only system that could do the job, Hydrorock. Since then, South Tyneside Council, together with Linus and BCE, have gone on to design and install other projects with Hydrorock following the success of Lizard Lane. Next case study here is Tilford Street in Surrey. Surrey Council, they liked the Hydrorock system and how it worked. However, the challenge was to produce a no plastic solution with no maintenance and under highway loadings. So, working in partnership with Surrey Council, we were able to produce a solution on the back of our rain garden design. The solution used high density blocks for load bearing under the road. You can see on the left hand side, the blue outline there just shows where the Hydrorock was installed in the ground. So we had the high density blocks for load bearing under the road. We had low density blocks in the verge, as obviously they are cheaper and under lighter loadings. And this produced 25 cubic meters of storage under the road, an additional 25 cubic meters storage of capacity in the verges, acting as one continuous aquifer regardless of which side of the carriageway the water entered the system. They installed rumble blocks were installed between the road and the Hydrorock blocks, allowing water to cascade through the top of the blocks. This project also helped highlight the ease in modifying Hydrorock around tree roots and other underground obstacles. Now, I'm not sure if you can see too well, but on the right-hand side, you've got some blocks there going around a tree. And at the bottom of the photograph, you've literally got 6 blocks wide narrowing down to 2 blocks at halfway up the picture as you go around the tree, returning back to 6 blocks as it continues. So as long as the blocks are touching, it will act as a single aquifer. It's also worth reflecting that both Kia and R&W, who installed the system, they couldn't believe how quick and simple it was to complete this project. Just before I finish, I'm pleased to announce that Hydrorock are now offering a project advisory service, which will offer 2 levels of service. The first will be free of charge feasibility study, which is an indicative or outline evaluation design. So what this includes, it would be an outline design just to confirm any assumptions and known parameters. We would give some basic details, just showing the makeup of the system, a plan and a typical cross section. And then we give some performance data with some indicative calculations so you can see how it would function. We'd also give you some estimating costs, and these will be broken down into 3 levels. So there'd be the initial cost of the product. Then we'd give you a breakdown of the fully installed costs, including plant, labour, materials, excavation, spoil away, etc. And then there'd be the third cost, which would be the whole of life. So that includes the fully installed costs, plus operation, plus recycling, etc., etc. Together with this, we'd also give you some installation timings, an estimate of that. And then finally, we give you a summary of the project with the value proposition, just highlighting details on the project, the cost, the environment, the project risk, and health and safety. And this will provide you with an excellent overview on the solution that best suits your particular project, with indicative costings and timings. You can then either go through your usual channels to produce a working design with support from Hydrorock, or you can use our detailed design service, which is our level 2, which is chargeable, but with discretionary discounts on the purchase of Hydrorock. So hopefully you've seen today just what a versatile product Hydrorock is. It's a sustainable product produced from a natural material that is in plentiful supply. It's effective and efficient in moving water from the surface back to where it belongs. It's cost effective, being quick and easy to install with reduced excavations, spoil away and time. And of course, it's flexible in working around those obstacles in the ground that are not always easy to find until the project is started. Very eco-friendly, especially with our no plastic solutions. And because it is so quick and easy to install, it minimises and sometimes negates any disruptions such as road closures. So that's the end of the presentation. Hopefully you found that of interest. So now it's time to have a look at some of the questions on the chat. But before that, I'd also just mention that after the webinar, we are keen to set up post-webinar surgery. So if you'd like to discuss Hydrorock in more detail, please either get in touch with me. My details are there on the screen. Otherwise, you can contact us through our website on the contact page, and then we can book in post-webinar surgery. So I guess with a little bit of help from Iona, look at some of these questions.
Hi, Steve. Yeah. The first one we have is from Kay Lacey, and they are asking, you talk about recycling at the end of life. What is their lifespan and how is their performance affected as they get older?
So generally the lifespan for Rockwool, for the Hydrorock with the Rockwool product has been tested by Rockwool, and the tests have shown it's in excess of 30 years. I think they stopped the test at 30 years with sort of a increased sort of testing system. Stone is generally 15 years, Hydrorock 30 years, and then once, it depends on also if it's loaded by runoffs, etc. So the quicker it's loaded, obviously the shorter the time span, but you're talking a minimum of 20 years, generally excess of 30 years. Will I answer the question there?
Thanks, Steve. The next question's from Emma Mills, who is asking, is there an offset distance for tree planting from the system?
Is there an offset?
Is there an offset distance for tree planting from the system?
Do apologise, I don't fully understand the question. We have tree pits which we use for obviously irrigating trees. So there's no minimum or maximum distance away from the from vegetation. Obviously, the closer it is, the better it will irrigate. But the trees, etc., can be planted right next to the Hydrorock. Generally, they don't penetrate, but if they do, it doesn't compromise the system at all.
Thanks, Steve. Next question is from Kirsty, and she's asking, what is the cost difference between plastic crates and Hydrorock?
Again, I would love to have this conversation in more detail, because if we talk about the actual cost of a crate against the cost of Hydrorock in terms of cubic meters, the cost of Hydrorock will be more than crates. If we talk about the installation costs, Hydrorock is cheaper, and if we talk about whole life cycle costs, we're cheaper still. It's worth knowing that generally the systems with Hydrorock are a smaller solution. It's worth knowing that you don't have to assemble the Hydrorock. It comes ready wrapped. With crates, you have to build them. It's also worth knowing you don't have to build the extra meter width around the crates to allow access to wrap your crates. So happy to discuss that further, but I would prefer to discuss the actual sort of solution costs. If you're just talking about the cost per cubic meter, then that's not really the preferred way to consider Hydrorock.
Thanks, Steve. So next, Dave and Anna are asking, have any water companies adopted these systems? And if not yet, is this something that you are considering?
No and yes. Hydrorock came into the UK just over a year ago, which was perfect timing as a pandemic kicked in. So where we'd like to be is we're out by 12 months. But this is an area we're looking to develop our conversation. So certainly with water authorities, certainly with the environmental agency, certainly with Network Rail. We've had some really good conversations with a lot of people at the moment, and we're looking to sort of pursue that further. Okay.
Thanks, Steve. I'm just getting the next question out. We've got loads popping in. So just bear with me one moment.
I don't know if my colleague Headley's out there, one of the founders. He's supposed to be on holiday, but he said he may be joining us, and happy for Headley to join in if you're out there.
So the next question I've got here, Steve, if you're ready, is where is Hydrorock manufactured and where is the rock sourced from?
Can't answer the last one because I don't know, but it's manufactured in Denmark, and then by Rockwool, it's then fabricated in the Netherlands by Hydrorock. So the basic product is a Rockwool product that is then modified. You put the hole through the center, it's then wrapped, and it's then produced then by in the Netherlands by Hydrorock. The idea is being that as we start to introduce it into the UK, that it would be manufactured by Rockwool in the UK, and then we'd have our fabrication plant set next to that to convert to the Hydrorock solution.
Thanks, Steve. Okay, so next up, Jamie Cooper is asking, how does maintenance frequency compare to that of crate storage?
Maintenance is absolute minimal, and I would reflect on the maintenance of Hydrorock a little bit like, you know, maintaining your car. Hydrorock's a bit like just checking your dipstick now and again, as opposed to a full-blown maintenance. So if you look at the system where I showed you with the filter gully, where the water sort of goes through the filter gully into the outer blocks, So within that filter gully is a sock or a bag, and that will filter out the sort of the silt and the debris, so it doesn't get into the blocks. That bag, on a sort of fairly infrequent level, would just need to be sort of removed, turned inside out, and just sort of washed out. It's no more than that. If somebody forgets to put the bag back in, so you get some sort of debris, etc., going into the blocks, it's fairly quick and easy just to sort of to put a pressurized hose through the middle and just sort of clear out any debris or muck that's sort of that's moved in. So it's low maintenance to look after Hydrorock.
Thanks, Steve. Unfortunately, we won't be able to get through all the questions today, as some of them do require a little bit more detail, but we will make sure to reach out and email with some of those questions that do need more detail. But to finish off, we've got a question from Matthew Woods, who is asking, how does the system cope with freezing temperatures?
I can't remember off the top of my head what minimum temperature is, if any. All I know is it's not a problem, and I'd have to thank you for finishing on this one. I don't know is the honest answer. I know it's not a problem. I will have to get back to our technical departments and come back to you with an answer, but I can certainly do that sometime today.
That's great. Thank you, Steve. If there's any more questions or you need any more details, please do get in touch with Steve in the details on the slide above. And yeah, thank you all for joining.
Thank you very much. Thank you. Have a good day, and hopefully I'll speak to some, if not all of you, in the near future. Thanks very much.